think it's, yeah, perfect. Yeah,
You got it.
Yep.
Perfect.
Put it
That's
over,
awesome.
Put it over there.
Thank you, Roger.
I think we're ready.
Thank you for joining us, everyone, because today we are celebrating the end of the tyranny of paper maps
I'm
and
telling
the
you.
folding of paper maps. That's right. We're entering an age of digital access to the types of maps you might use. And we're excited about that today because it's GIS Day.
Absolutely.
It's actually GIS week. And so great things that we're going to be doing today, not just getting rid of our paper maps, but taking a look at the great things you can do with data and mapping and wonderful things that you can do online with your students. In fact, I'm going to show you some free things that are available today that you might want to start using right after this broadcast, actually. Go home, do it now, do it on your phone. You're going to be very excited.
Stay with us,
about
though,
this.
because you do want to see what we're going
Oh,
through.
yeah,
So,
yeah. There's a whole bunch more going on here. So, of course, this is Roger. He is our famous GIS, GPS, Esri guy, and I'm JP. And a lot of people always ask what that P stands for. Do you know what the P stands for, Roger? Known you a long time. You know what the P stands for?
Every week we just I gotta keep thinking. Probably not.
No,
No,
you never
I'm
get
not.
it right. The P actually stands for
Oh,
puppies.
puppies.
I know, it's a strange middle name. Thank my parents for that, but it stands for puppies, and it's appropriate because here on National GIS Day, we are taking a look at a very easy way you can get your kids involved. You can get involved in looking at mapping and the data you can pull back, and we do it on the Global Pet Survey. It's a very easy survey. Actually, it only takes all of a couple minutes, but the data you can pull from that is huge, and it gets you right into understanding mapping and the great things you can do with mapping. Here's the website. It's a very easy esri.com/pet survey. And once you get into this survey, all you do is answer a couple simple questions, just like you would be out in the field, answering questions with some simple data like, what pets do you have? Where are you located? How many different types of pets do you have? And when you're done, you get this great interactive map that gets to show you all the great things that are being collected. Now, currently, there are a little over 500 people, and we expect that after this broadcast, there will be another 500 people, and they just keep collecting this data. And of course, with all data sets, Roger, the more data you get, the more great things you can do with it and the wonderful stuff you can pull out of it. So use that, but you're not just looking at like dogs and cats. You can look at dogs, cats, amphibians, birds, farm animals, insects, and then once that data is collected, you can get to narrow it down and take a look at places like here in Panama City. I actually took a look at this one place in Panama City. Somebody input their data, and what do they have? 2 birds.
Wow.
Yeah, 2 birds, and you can see it right there. So that's like one little piece of data you can pull. Or I went over to New York. Somebody had put their information in about New York, and it's like, oh, I've got amphibians. And not only do they have amphibians, they even uploaded the picture. So I get to see what the picture is of their amphibians. So
That'll be a
again,
crocodile they flushed down the toilet or something. No, it's the frogs.
These
Okay.
are frogs.
Okay.
These are frogs in New York, and they're right there, and they're listed, and you get to see that. All of that data is available. And so, Roger, we're collecting that data, and it's in there. And actually, even with just a little over 500 people, there we can see what like the top 3 pets are out there, or what people are declaring as their top 3. Do you know what they are? You want to guess? Do you want to guess what the top 3 pets are so far?
Okay, I have to go with dogs.
Okay, so is dogs number 1?
Dogs are probably number 1.
Okay, who do you think number 2 is?
I'm gonna go with cats then fish.
Okay,
so that's my guess.
He thinks it's dog, cats, and fish. Well, we take a look at this, and we actually find out that it's dogs number 1.
Okay.
Cats number 2.
Okay.
And farm animals.
Okay.
Farm animals is number 3. Tied almost with fish tanks.
Okay.
Fish tanks is at 99 and farm animals is at 101.
Okay.
So very close run there. Let's see what happens after you guys put your data in. You get your students to put their data in, and let's take a look at who wins as far as pets are concerned. But it's not just about pets. If you want this free opportunity, go onto that website again and take a look. They've got these young storyteller map ideas that are there for you and your students at all ages. What I'm showing here are some early age opportunities, but they're there all the way up through high school, all the way through college. Great things you can do. And then if you really want to get crazy with it, you can take that data and hop right into ArcGIS, GIS Online, and really explore that data at a very, very high level. And of course, all of that is possible just by going to the esri.com/pet survey. And I'm excited about that because, yeah, we're PASCO, but PASCO is partners with Esri.
That's right.
And that allows us to do some things outside of this kind of like pet survey you might want to be doing some science collection, which is what we do here all the time anyway, right, Roger?
Absolutely. And while pets are great and they will engage even your youngest of viewers, I think things that we can measure outdoors is also a great way to engage students of any age.
And what can we measure outdoors?
Well, today I was thinking we should go out and take a look at some of the moisture that's available in the soil, for instance. And the soil moisture sensor is a new, our wireless version is newly available. And so we are excited to sort of talk about ways that we can use that specifically in this sort of telling story capability with maps.
So maybe if you don't want to do puppies, you want to look at soil moisture. Roger, you're actually going to show us what this soil moisture device can do, because it's kind of new, and it is measuring clearly. It's got the ability to be pushed into the soil, and it's going to be measuring moisture. Can you show how that works?
Sure. This is a little circuit that comes down along this blade, and that will create a field on both sides of these. When you put this into the ground, water interacts with that field and then changes its sort of electronic signature that's measured here and then sent to the base unit. Now that can either be sent to your phone, it can be stored here, just if you went out in the field like we did, and I'll show you some examples, and we just measured a bunch of places and then sent back to your computer, and then we'll talk about how to tell the story of what that soil moisture is. Now, to give you a feeling for what that looks like, let me pop over here, and inside of our software, I'm going to bring up SPARKvue.
So that's interesting. You mentioned that it's in our software. So the maps that we were looking at, even when we were talking about the pet survey, that same type of map is already embedded in our software. In SPARKvue, all of our sensors are connected. Any connection that you have to any of our sensors, you want to use your phone, it's already got GPS in it. And through SPARKvue, you can already start mapping this type of data. So you want to map this type of soil moisture data? Great. But it doesn't just stop there, does it, Roger? You can probably map almost anything. Like if I wanted to go out and do wireless light, could I do it?
Absolutely.
If I wanted to go out and do wireless pressure, could I do it?
Pressure with your GPS on your phone is going to tell you what that light is where.
If I wanted to go out and do temperature and measure it throughout different areas, could I do it?
Where it's warm, where it's cold.
Could I do it with the weather sensor, Roger? Could I measure all the things and map it with the weather sensor?
Tell if it's a dry heat or a damp cold.
And how about this, Roger? Carbon dioxide, dissolved carbon dioxide in the water samples. Could I map that?
You said it. You can't breathe it, but it is there for all the fish and those that can. So I think we're in a good place.
This is amazing for those of you who are out there doing field studies and want to do some actual collection of data. Tell me about this wireless moisture sensor that we're going to use today.
So I think you'll get the idea. When I put this into this just open cup, I'm going to pour some water in there, and you're going to watch to see what this sensor does, so how it responds. First, it's in there. It's got a few drops from my test run. So it can sense a little bit of water that's in there. If I just sit and watch this now, I'm going to pour this water into the cup. And you'll see that as I'm filling this up and the water takes up more and more percentage of the space on both sides, that changed that electronic signature. And so that is now being saying, hey, 55% of that space around this blade is water.
So if that were filled all the way up to the top of the blade, it would say 100%. And so we're doing the same thing in our soil sample.
That's right.
We're pushing it all the way up to the top of that blade, and we're getting a measurement of the moisture around that sensor, correct?
Exactly, exactly. And it's a little more complicated for water or for soils because there's spaces in soil. You may think it's hard, you fall on the ground, but there are roughly 47% of soil at the top level is got some space to hold other materials, gases, like carbon dioxide or nitrogen for plants that need to take that up, and spaces where water can go. So we're going to just test this one. This has about 15 or so percent. I measured, a certain volume of soil, and then I also poured a certain volume of water in there and shook it up, just so you can see as we take a look. I still have some water that's on the blade, but that's all right. We'll get it and take a look at me.
So you push it all the way down into the soil, all the way, and I'm getting about a 12% soil moisture content. Now, when I look very closely at your display here, Roger, it says loam. Like it's telling me that this is a loam measurement. What is that?
Well, there are types of soils, and if we think about soils as a triangle, usually they think soils are made out of sand, they're made out of clay, and they're made out of silt. And those are different size particles. But most soils are a mix of those. So if you go into your backyard, it's not all sandy, it's not all clay. So generally, we, instead of saying those three, we chose loam as one that we have calibrated this probe, knowing if it's got 20% or 40%, we know what the readings are, and we're going to read those out as a percent moisture right on that probe for you.
So most people, if they're out in their garden or in their yard, it's going to be set to loam. But that's not the only measurement you can take. There are other measurements too, right? It says here, I see clay, and it says sand, right?
Right.
So this is a clay sample, for
Right.
example.
If you
and
get
it's
clay,
different than the soil sample.
That's right. And if you know it's predominantly clay, it's sticky. It'll be like pottery if you've ever worked with those. Or if it's sand, it's gritty like in a creek bottom. So choosing the type of soil will give you, they're fairly similar in response, but it is tuned to those three most common sort of soils that you're going to experience when you're out in the field.
So speaking of going out in the field, why don't we try that? So this is a great demonstration for in the classroom, but ultimately you want your students to go out into the field and measure some soil samples. So we sent Roger out into the field.
That's right. And you may have seen some ads on our previous either Earth Days or GIS days. We're just going to connect the phone to this sensor. And so while I'm out there, I've got two devices, and really that's convenient. I can hold the base in one hand, and we can use this in the soil to be measuring. Obviously, it took some time to do, as you're going to see how many soil samples we had. When I open this on my phone, you're going to see the first step is choosing a path. And I'll say, oh, I'm going to choose a sensor and tell it it's the soil moisture sensor. Also, though, in there's going to be some onboard sensors, like the GPS. The GPS is a global positioning system. It's communicating with satellites to tell you where you are. Okay, that's the way Waze or other kinds of maps work, is they know where you are through the GPS. All right, so once I turn that on and I'm connected to my moisture, I'm actually getting three pieces of data: latitude, longitude, and your soil moisture. So we set the soil map up. And as a matter of fact, one of the types of pages we can say is stream a map in the background. So when you're sticking this into the ground, you can see it on the map itself.
It's constantly collecting the map and that information, and it's layering them together simultaneously.
That's right. And so our business here, PASCO, is on the right upper side. You can see that. And we're going to check that field out just above it and to the left. It's right in the middle of the view, right under the untitled page. But when I collect that data, it's going to start showing up on here on an automatically chosen for you color scheme. So you may or may not like that color scheme, and that's fine, but it's definitely going to inform you as you're collecting what the value of the soil's moisture is. Red on this scale is the higher values. So you can see that that field out there has got some places where there's some moisture.
So what I'm looking at, Roger, every one of those little dots is where you stopped and physically took a measurement and then collected that measurement and moved on to the next spot, correct?
Correct. Many times the soil moisture sensor is we would say, hey, dig up the soil and put this in there and then pack it in nice. Now, I went and tested 400 plus places, so I'm not digging up the field with that many. I took a chisel, jammed it into the ground so that it wouldn't wear the surface off, and then we just pushed it down into that hole so that it would measure that moisture. And it did speed up the process by quite a bit, I can tell you. So that's what we use inside of our app. Once you were in the field, I can hit this little, looks like a V shape that's sideways, or that angle in the upper corner, and I can share this lab back to my computer through email on the phone, or I can send just the data. And that I'm just going to email myself back here at the computer. Once I'm here at the computer, I can either open it in our graphing software, or I can save it as a table. Now, what you're seeing here is once I have the table, we can put it into a map where we have all the data about other things about soil, like the soil type, or if there's land cover, things like those.
So we're really giving people two opportunities to work with the data. You can keep that data in our software,
yes,
and do all the analysis in our software, the linear analysis, dropping on a graph, labeling it, all the great things that are in our software you can do. But the high power of our partnership with Esri is that you can actually now take that data and put it to ArcGIS Online.
Right.
And there is no cost for that, is there?
That's right. Any viewer can go on, and if you just use the map viewer, sort of it looks like a tab at the top at arcgis.com. There's a map tab. And once you're in there, you drag your file, your CSV, comma, separated value, drag that onto the map itself. And literally, it'll ask you, where is your latitude and longitude? What column has the word latitude? What column has the word longitude? And it gives an attempt at taking one of the other columns. Well, I did record some time, so I don't like that. We're going to change from time into the percent water inside of loam. And when we do that, we see,
bam, it's that data now dragged into ArcGIS with a much more powerful opportunity to do analysis just with the mapping.
that's right. And so we have a great map that has some color choices. And if you don't like those color choices, inside this little table of contents on the left, you can change those. You can move some things, and that's great. So you can get it to look the best story you want. And so that's great. That's still free. You can take a screen capture of that, use it in a report if your students are doing that, or if you have a school organizational account, you save it for longer term, just like any other online software. If you have an account, you save it, and now you have access to it whenever.
That is a great, powerful tool for collecting data and dropping on a mapping.
But
and
wait,
this is a great tool for soil moisture.
That's exactly right. But there's more,
There's
and
always
I
more.
can't
That's
say
great.
enough.
There is always more. This was soil moisture,
Yeah.
but I know it's going to go further than that. We already showed all the great things that you can use out in the field. Show me, Roger, show me.
We can't just say, we can just see our data on the map. But since it's GIS Day, let me tell you, we have a special for you, and that is how to do powerful analysis with these same points. So in a desktop software, I've taken exactly that same field, and I flew a drone over it, and we pulled all that data together and made one single picture out of probably 100 pictures. Now, you can still use the streaming data, which is great, but this one shows me exactly what that field looks like while I collected that data. The next thing, I put those points on there, just like you saw inside of the phone or that we dragged into the online world.
So these are the pictures you took,
That's correct.
assembled through their website,
Yep.
dropping
Through
your
their-
data on it.
And this is now software. So this is desktop, and it does have more power, so you can pull together these sort of images, and I can pull that CSV into it, just like I did on the online version, and I mapped it. You may say, well, it's all one color. Well, this is 1 week after that huge rainfall. The atmospheric river came through and lost about 10 inches, 8 inches of rain.
We had a very wet day here, and then after that wet day, you went out and collected data, and it said it's wet.
It's all wet.
Not a big surprise.
Right. As a matter of fact, you look at the table of contents, it's around 38 to 75. It's actually around 45 to 50 is what that exact value is. But it just put a branching sort of, it captured all of that. Now, one thing we did say is, what if we came back a week later? And here's where the power of GIS is now you can see it's coming down more in those yellows, 11%, 8%, even 5 or 6%, as that field is drawing out. As a matter of fact, I came back even the day later just to see if there was some changes. You can see it's even drier on a good sunny day, and it'll dry out a lot in just that short time period. Now, that's pretty cool, but what the power of knowing what those values of soil is, I can't compare one to the other because I didn't go back and find the exact hole 1 week later or even the day.
Right, in the exact spot, right.
But if we want to compare these, I have to get a continuous
Sure.
surface.
Look
in
at
a
that whole area.
graph, we call that extrapolation, where we connect the lines and we say, oh, I know every point on that line is probably following this model. But here I can do it in a 2D or 3-dimensional space. I'm going to say, oh, let's connect all of those values so that we get a color version of every place in that field based on what we did measure. That is an extrapolated version, or interpolated and extrapolated, went beyond and it went within. And so we have a great map that we can see. But
Nice. Now we're taking a look at those pictures, and it's actually looking at the elevation
Right.
and dropping that in also.
so not only when my drone flew and took those pictures, to put those pictures all into one, it also knows where those spots are. Just like our eyes are two different perspectives, they got an elevation information. And I put that data in there, that continuous surface we talked about of where water is. So if I turn this on, you saw the previous picture was where the water was 1 week after. Now this is now another week later, 2 weeks afterwards, and I see the topographic features.
I
and
can
start
see
to
the
understand.
elevations, and I can see the moisture at the different elevations.
It makes way more sense than just looking down at the top. You can see in the green sort of on the right side, that's at the bottom of the hill, and that's where that water, because the water follows along, it's pooling in those areas and it's still quite wet. As a matter of fact, from that day to the next, I can do a quick comparison. You see it's even drying out from one day to the next.
We would expect that. So now it kind of makes sense of the data because I can see the way that the ground is sloping. I would really be expecting the way that the water is moving and helping me establish water tables and water gradients as well.
Now, we can do this analytically. Yes, we visibly see that just by the coloring and choosing those same scales on both of those graphs, which takes a little bit, but I can literally subtract those two surfaces and say, oh, this is where the water is missing in the red, And that's where it was missing from a week ago to 2 weeks, from 1 week after the rain event to 2 weeks. And red is showing where a lot of water is out of that soil. It's drained out. The blue isn't changed as much. It maybe is more clay, and so it's not leaving that area. The sandy area is probably it is leaving faster. So that's my hypothesis.
Oh, right. Because we can see a lot of things happening here.
Right.
And we could actually go back and do some higher level investigation.
That's exactly right. And even 1 day later, this is from the 1 week till then 10 days, from 13 days to 15 days. 1 day later, you can see there's even a change in the water.
Oh,
just
right. A
1
rapid change,
day
sure.
of nice, warm, sunny day. Now, that's not the only thing that we can measure. I mean, that was a great study, and you can learn a lot. And hopefully you saw that was obvious.
It looks to me like you could take data, simple data that we had, turn it into a powerful map, take a look at elevations, get it three-dimensional. What else could you possibly want to do, Roger? It just sounds to me like it's Christmas morning with everything.
And there's still way more boxes under the tree. So if you have a colorimeter, you can take the vials that come with it called Easy Snap, and you can suck the water up into those, and they'll tell you what nitrates or ammonias or the fertilizer amounts in there. And we have a map that's showing, in this case, red more fertilizer than the blues across the town right here.
Interesting.
In our area. That's just a little local creek. You could do that with your students.
With a colorimeter.
That's
Good.
right.
Measuring nitrates. All right. What else?
Okay. If you get your students, you say, hey, I'm going on a field trip sometime. We're going to go down to Mud Island. If you've ever been to Memphis, it's a model of the Missouri River. It's a museum for the Missouri River. And you get in close and you just take this oxygen sensor. It's got a temperature and oxygen amount. You drag that down the little model of the Missouri. And you can see on the left side, temperature is based on cold for blue and warm where it gets warm on a nice warm day. It's red. And so you see the water as it flows through this model of the Missouri is warming up. But the oxygen is in the other color, like your blood colors.
Right, the oxygen's changing with the temperatures of the water, and we're mapping it, and we're taking a look at that, and doing that within the software.
Right, and so they can see there's a relationship between temperature and dissolved amounts of oxygen, just like there would be in a soda that you'd open up. If it's warm, it goes flat, fast, the gases leave.
Or
we could do a conductivity sensor. And if you walk along a cool creek, this is just a creek that flows from left to right, it gets saltier as you go by a factor of 5. That's a lot of salt to be in a river system. So my students were really interested, like, hey, does this affect what lives there? And of course, we took some cool nets and we caught some of these at one point in time in my career as a teacher, and we were able to classify things that are big and stout like this are less tall, or they're not so sensitive to pollution. But if they got really fine tails and they're very sensitive to pollution, or if they're a snail or a slug and just slimy, they aren't sensitive to pollution at all. And they map those two things.
They were able to put those things together in their own kind of map and tell their own story based on the data.
That's right. And we gave them chances to tell the community about the water in there. And it wasn't unnatural sources. It was just a local, different kind of an aquifer that was leaking and made it saltier. The final thing is, maybe you're just going on your way to work and you're driving and you stick a
And
pH
everybody
probe out
wants
the
to
window.
do this on their way to
I'm
work.
telling you.
On your way to work, just put the pH probe out the
You'll be
window.
the hit of the party and you'll have stuff to talk
Close
about.
it in the window so that both hands are on the wheel, Roger.
Absolutely. Or
Right,
get somebody
yeah.
else to drive
Sure.
with you.
Yeah.
Okay. And then you'd be gathering some information. That is 1,000 times more acid when you cross those highway areas in the middle of Dallas. Matter of fact, this was so interesting, I couldn't help myself. And the next weekend where it rained all day long, I took a 250-mile trip around Dallas, circles. And we were able to see that the pollution not only generates, or the acidity generates around the center of the city, more traffic, more businesses, but it also flows with the wind direction.
Oh, that's crazy. And you didn't have the weather sensor with you to see to show the wind direction?
Well,
you just kind of knew it?
It was one of those kinds of things. It was an all-day kind of thing, and so I thought, the weather wasn't going to be consistent, but it was consistently, the weather moves that direction across in Dallas.
For your next trip around town, Roger,
Yes.
take the weather sensor with you and your pH sensor.
Absolutely. So we love doing this because every variable tells a story, and that's important for your students. They'll fall in love with this idea that they can talk about their community, measure their community, and have a great time, because that's the most things they remember. They'll come back to me and say, oh, I remember this trip we went out. It was always when we're outside doing something. More than I think I'm brilliant in teaching.
And they're going to remember the data
remember
that they pull out of that and the conclusions that they were able to draw.
That's right.
And data is data is data. Any variable is a good variable, whether it be puppies,
That's
which
correct.
is a variable, your pets are a variable, or temperature, which is a variable. These are all variables that can be done easily and wonderfully using either the free thing that we offered you at the beginning where you just go online and enter your pets, or it's actually free with the download on your phone with the software. Pick up one of our sensors, map it directly on there, or drag it into the free online ArcGIS and do all this higher analysis just like Roger did here. That's why we call him the expert when it comes to GIS. You can understand exactly why that is. Every day, Roger's out there measuring some form of data and dropping it on a map, and you can too. Thank you, Roger,
Absolutely.
for sharing your mapping love with us, and thank you for joining us. And Roger and I are going to get back to trying to fold that map.
We'll see how it goes.
See how it goes. And while we're doing that, of course, we wish you the best of luck, great teaching, and good day.
Good day.